Welcome back to Suit Up and Hack. In this video, we're going to take a look at another deceptive malware dropper, or as I like to call them, deceptive droppers. Right now, this looks like a single line of semi-meaningless code, but it's actually a complete malware attack. In this video, I'm going to take this JavaScript file, single line, beautify it, and break it down exactly to show how it decodes a hidden executable on the victim's machine. Alright, as we jump into this, we see there's just a single line. This is how it was provided to me when I went through, downloaded it from Malware Bazaar earlier today. Decided to unzip it and received this one single line of really long JavaScript. Had to go through, beautified it, and this is what we ended up getting. So what we see immediately here is the setup, in which we have a try and a catch block, which is basically an error handling block, and we have right here this string prototype ends with, which is just a piece of code that adds the custom ends with function. Modern JavaScript typically has this built in, but older JavaScript engines used by Windows Script Host might not. This just adds it to ensure that it can check the file extensions later on. The payload here is this var aso ibore with a very long Base64 encoded malware executable. This is the payload. It's actually a complete Windows executable that has been encoded in Base64. And in another video, we're going to decode it, drop it into a disassembler, and see what it does. Next part here, this var silver and cinema, along with the bin.base64 and cinema.txt. This is the way that we're going to decode the Base64 string. It uses a built-in Windows tool, XML tool, to do the heavy lifting, creates a temporary XML element, tells it that its data type is Base64, and then voila, the object is automatically decoded back into its original binary form. Sugar is not the typical sugar that we're thinking of here. Instead, what this section is doing, it's preparing to write the file to disk. It creates this data stream, and it sets the type to 1, which is representative binary data, and writes the decoded program into the stream, where it's then holding it in memory. Next, this code block here, it's going to basically gets the paths for 2 Windows folders, the temporary files folder of temp, and the user's application data folder of app data. Malware often uses these folders because they don't require administrative permissions to write to. If we take a look then, we have this list of items and service we need .exe. That's what we can think of the name of the executable. So it's kind of a social engineering trick, I guess, if you want to think of it that way. So it looks, meaningless. someone looking at, oh, list of items and services we need, and maybe not looking at the .exe file. But the isTemp flag is set to false. And then this sugar, let's see here, the sugar.toSave path, 2, this is that drop. It takes the binary data from the sugar stream that we talked about up there, that data stream, saves it as a file at the location we determined previously, and then the 2 means that it'll overwrite that file if it already exists. That means that that malicious executable is now on the computer's hard drive. Finally, this else statement will execute because path doesn't end with .jar or .vbs or .wsf. No, it's going to run what's there in the executable that we set earlier. So in summary, this deceptive dropper, it's entirely in Base64. The script uses a Windows XML object to decode the string back into a usable program, drops it into the user's app data folder with an innocent looking name, and then finally creates the executable and runs it in order to put the malware and execute the malicious code on the user's computer. Next video, we're going to go in and dig into the Base64 executable. Thank you, and make sure to check out that next video you're seeing in your screen right now.